First off, everyone, just welcome. Thanks for joining us. I'm excited that we have such a good turnout today. Today, we actually have Bo Guo from Gistic Research Inc., who I'll be introducing shortly. And I'm actually just going to jump into it. I'm going to skip the background we normally do. I think most people are familiar with the background and all of the stuff on LinkedIn, so we're going to hop right into it today. So today, our presenter is Dr. Bo Guo. Bo is a veteran practitioner and researcher in the GIST space, and he's also the creator of the Linear Bench product line. His doctoral research in temporal LRS also contributed to the ISO standards of GIS LRS 19148. Bo's new and recent passion is building collaborative GIS editing platforms for various levels of government. And aside from that, Bo, as he kind of mentioned, actually really enjoys a minimalist and nomadic lifestyle. Bo frequents traveling across the country and choosing different cities to live in, and staying in long-term Airbnb so he can experience different cultures and different ways of life all across the country. And on top of that, talking a little bit more about FME, in light of Bo's database background, his two favorite transformers. This slide didn't seem to actually update. It should be the feature joiner and the inline querier. Bo really enjoys the inline querier and the ability to build SQLite databases on the fly and use his SQL expertise inside of FME. And again, I'm not sure why that didn't update. Bo's least favorite food is not pickles. Bo doesn't have a least favorite food at all. Bo loves all foods, regardless of where they come from or what they taste like. Bo just loves food in general. And with that, I'm going to go ahead and let Bo take over and give us his presentation on the LRS Custom Transformers he's published to the hub that are freely available for everyone to use.
Thank you, John. And it's true, I don't have any, any food that's edible human food I enjoy. That makes my nomadic life quite a bit easier, as I'm not as picky, generally speaking. All right. Let's get started here. Okay. I think the first question that should be asked, why LRS Custom Transformers? And by the way, I'm going to kill my video because I'm using my hotspot in this Airbnb. It allows me to do that here. Should I lost my. Oops. Sorry.
We can see your screen, Bo.
Okay.
So.
Yeah. I like to consume stop video. Yeah, here. So hold on. Okay. Yeah. All right. I think I'm set. Before we answer this question regarding why LRS, we need to look to what is FME. And to me, FME is a data platform, or we can consider that being a development framework. As a development framework, such as maybe Angular, JS, or some Java, other C# platform, essentially, it gives you a bunch of tools and overall framework so that you can build your own solutions. I think more or less FME is designed in that way. So anyone is actually using FME to do your solution, you're effectively a coder rather than a just analyst, because you're building solutions. Okay, and one other thing is LRS is not easy. It's not an easy solution. Why LRS is not easy? And I think there's the event and route separation. They're separated. And there's also another separation called event to event separation. We know ADT is stored in its own physical table, just as through lanes, county codes, urban codes, and facility types. So many different attributes. Essentially, one attribute, one physical storage table, if you will. So that making things, essentially they are not directly related. And then there's a duality of location representation. think about it. Location oftentimes can be described. In fact, the LRS, it describes location so that human can understand and think about, hey, we have an accident happened along or on I-10 along a particular milepost. But there's also a geometry representation of that, the XYs, if you will, in this situation. So there's two aspects of that. Which one you think is authoritative that needs to be used? And that can cause a few issues. There is another, a time-space, I should have removed that economy. It's a time-space duality, and which I need apologize for that. And adding a temporal dimension to it further complicates that. And, just today, I just noticed that Eric gained quite a bit of new hair, at least his hair, gray hair, is more pronounced. I think for some degree, it has to be, LRS has to be blamed as part of it. Then, because it's using custom transformers, we can make it reusable. We can make it shareable. It's easy to extend. And by the way, SME customers, custom transform can be really, really powerful. And speaking of, by the way, I intended this to be really a informative and interactive presentation. So by all means, stop me and we can have this conversation, a journey going through some of the things that we have experienced, over the past, I would say 5-6 years, as we started building LRS custom transformer and gradually putting them online for public access. Well, let's look at the event operations. And typical operations that, as we all know, that we have the event-to-event overlay, and we have the event line-on-line overlay does this. And we also have event point on line that we can leverage. Then event area overlay. So you have the event overlaying an area. You want to have the area boundary, either leaving or entering the area. You want to have the measurement. So there's the event feature area overlay. While we put a feature over there, we're indicating in this case, we want the geometry to go along with this feature event. So typically, in many places, we have event, means it's a purely the definition, the location description in the form of en route at measure point or from measure point to measure point. But in the case you have, say, event feature, so in addition to the definition of location or description of location, we need actual geometry to go along with it. Of course, that can also be computed. Then we, of course, have geocoder. And I think about less than a year ago, I published a blog article thinking we should do away with dynamic segmentation, but using geocoding. I think it's more in line with the concept of converting the description of location into a physical XY that is congruent or referencing a particular description of our location, such as a particular linear referencing system. Then along with that, we have the LRS reverse geocoder. Then we have event merger. So why we have event merger? Because we like, I think it's more efficient if we have less events to deal with. If we have two events having exactly the same attribute adjacent to each other, we use event merger to automatically merge them as one instead of two. Such as you have two adjacent values all have the same urban code, you would want to lump them together. Then let's look at the root operations. We typically have bulk root builder, and that essentially saying I have a bunch of center lines. Each and every center line is attributed with a common root ID, could be in the form of a string name plus city or urban code or what have you, right? So it should automatically build them in the bulk. Then we have the root calibrator, and also this is one of my favorites, and root intersection. Essentially building the intersection to intersection relationship, in a table. And the importance of that to me, it gives a human understandable reference point, because we would like to refer to many things, especially the expansion of state highway into supporting local street. We like to describe attributes and events using intersection offset, and this allows us to do that in a more humanly understandable way. Now let's look at the analytics side of it. We have the event dominance. So let's say we have along a 10-mile long segment, single segment, and it has 2 or 3 AADT segments along it. So we're going to identify for this, this specific stretch of highway, we're going to pick the most dominant event of ADT to describe it. So that's the dominant event. Okay. Then we have the event summary. So within the 10-mile long segment of a freeway, let's say, we summarize it so that we know the average rather than just the maximum, the average ADT along this. So this is the event summary. And event overlap, I put into analytics so that we know, hey, I have an event over here. I would like to know what are the events I'm overlapping with. This could be I have a shoulder type of such, a pavement type, on the overlaying a AADT value so that we can see the relationship of that in a tabular form. And of course, we have the Q here. And because of the 2 dualities and also 2 separations, and there are many opportunities to create errors, and which we will talk a little later here. Then we have the route Q here. Yes, route can have many assortment of error conditions, as we all know it. In fact, and there's also single line queues here. So yeah, Sean Perfect of Ada and my dear friend John Erwin of Gistic, they allowed me to borrow their slide here. And they just finished I think a week ago today, they presented a really, I thought it was a remarkable presentation at RHOC. Some of you might have tuned into talking about the Road and Highway QQC executive dashboard, the making of that dashboard. Underneath hood, of course, majority of that was actually SME process. And so here's one talking about event queues here. Essentially, we do not care too much in this case about the attributes itself. We're talking about the topological errors within, we're talking about topological errors within or among events. Well, in this case, it's actually within a single event. And so we know sometimes we cannot have, some events, we want to have full coverage of route. So in this particular example, this event does not cover the entire route. We need to identify the gaps. Then event cannot exist beyond the route, the extent on which it belongs to. So this extent error. Then we also have overlap rules. So within a single event type, we shouldn't have overlap, okay? And just like ABT, within the same time domain, we shouldn't have that, because if we have that, there's either a duplication or contradiction that's violating the relational database concept. So this is a must check. I think the event extends and overlap usually should be captured. Now there's another type which Sean and John didn't mention, is the event irregular event. Think that you might have event with from measure to measure being null, or being simply in non-numeric values, right? Or you can have the from measure to measure being flipped in terms of its sequence, things of that nature. Then route QC, this is also from John and Sean. In route QC, one of the things kind of for hidden, difficult to identify is the non-monotonic measurement. So you might have two verses having exactly the same measure, or you don't have measure on certain verses. Maybe if you do not have measure on certain verses, that's acceptable, but having duplicate, it has to be monotonic. Otherwise, if an accident happens at this particular location, we have two locations on it. So it's not deterministic. So that's not good. Then we also have the ones actually switched. So even though the main direction is from left to right, but some vertices end up like, selecting in certain direction. These are real world examples. It's not something we thought might happen. And this happens in roads and highway, and sometimes can be quite rampant. And let's look at the variety of vertex inconsistencies, if you will. We all know undershoot, we can identify. We all know overshoot. We know about short segments, and we have quite, we often run into that. Individual segments, and I'm talking about the entire route. I mean, the route itself can be of multiple segments, but somehow there's one segment, even though they are all connected with other segments being so short. I think having individual segments is a waste of resource. It's not elegant, and so we raise this error so we can merge them as one part rather than a duplicate part, rather than a separate part. Then we have a small gap. Yeah, how small you can define a small. Then we also have tint or switchback of route. Believe it or not, it happens every now and then. Even in today's ADAS state route, we still find that. You have to zoom in real close to identify them. Then certainly identify route without geometry. And that's one thing. We also, at ADA, we also check for the route naming convention, because we have specific nomenclature of specific position and specific lanes, because our ADA's route is part of the intelligent ID, if you will, identified by the intelligent ID. It has pros and cons, of course, that because the intelligent ID, the specific position sometimes can transpose and shift it. We'll also check on that. Okay, another category, because for DOT people, us doing HPM is such a major driver for our daily work. There's some QC and reporting tools we have built. There's section file QC, and we have section HPM section QC. And we also have a section cross QC, because you there are certain rules, FSWA, each and every year we roll out some additional rules, and those rules are built into this cross-section QC. So different section files that, for example, if you are a freeway, you definitely shouldn't have let's say, dirt pavement, for example. Yeah, I'm just using that to exaggerate that. Yeah. TOPS reporting. It's a common thing. We like to build TOPS, in which I have, we'll go through something in this regard as an example. We have sample panel QC here. We have the statistics QC here. We also have the panel attribute QC here. So these are tools built available using FME, being really agile to use it. Yeah. Then there's Arno QC here, route QC here, which is the route QC here, essentially, but with Arno specific flavor built into it. Okay, any questions so far? Hearing none.
I'm not seeing any in the chat either, Bo. So you're doing okay.
And if anyone has questions, sorry to jump in here, Bo, but if anyone has questions, feel free to unmute yourselves and ask them as well. Bo really likes interactive things and to talk to people, so certainly don't hesitate if you have any questions whatsoever.
Okay, now let's move on to design principles for this, the LRS custom transformer. So one key thing is ignore the original event geometries. And instead, we abstract events as single straight line or point, or a square in the case of temporal, for temporal support. So why we do that? Because we are converting event into simple abstract lines. So this line will be computed in a geometric format using FME's geometric engine more efficiently and also more visually understandable. Because I remember a few, I think about a month or so ago, John was asking, maybe two. John asked me, so why you use, can we just simply use the full measure larger than 2 measure using mathematical computation to do, would that be more efficient? You know, I think efficient-wise, I would agree possibly it would be easier, but it can get really messy easy. So by converting them into geometry, we are moving this into the spatial domain, which FME is really good at, doing overlays and adjacents and merges. So we don't have to do those heavy lifting math, even though those might be faster. And also homogenize events into streams, into a stream or stream. So this is kind of like the guiding principle behind the building of the LRS transformers. And for example here, what is meant by homogenize it? So each and every stream, they all have the basic, on route, from measure to measure, from day to day, right? And have the event ID, typically object ID for that particular thing. Then, of course, for a particular type of event type, such as ADT or facility type or through lane. So functional feature class names. So all of them become a homogeneous thing that we can combine them and do it more efficiently. So that's that. And there are two hidden gems I would like to essentially use extensively in behind the scene oftentimes, because when you use it, it's kind of like the fundamental building block of LRS transformer. One is the event to straight line. The other is ST event. ST stands for spatial temporal event to square. And this in line with the design principle. And I will dive into this a little bit deeper. And we are halfway. I think we're doing fine time-wise. Okay. Okay, yeah, I need to switch before I come back talking about the stream pattern. Oops. Okay, so this is event to Streamline, and this is ST event to Square. And I have some statistics. Well, it's actually the very old sample data coming from Utah DOT. It's more than 10 years old when I was doing some consulting back then. So I built a custom transformer to just pipe in the data so that this data can be reused in many of our development efforts. Notice here is our development workspace. We use this to develop the custom transformers by building, this is a simplified version of it. I do not have the text. Sometimes I will add it. Yes?
Are you trying to show FME right now, or are you showing your slides? Because we're seeing your slides.
Oh, I'm showing FME.
Yeah, you need to switch your screen share. Sorry.
Oh, okay. Yeah, okay. So I need to, So, okay, I do need to share. Okay, yes, a separate screen. Right. So I think that this is the one. Okay, are you seeing this? The FME
yes.
was LRS _ event to SL, right? This one.
Yes.
Okay, cool. Okay, upper left, the custom transformer is a linked custom transformer, so we can pipe in data to be used for various development FME workspaces. And so this is building Streamline, and it's pretty simple, but I also like to show a different rejection. We have a rejection code. Why is that? We think it's important. So I'm using sampler to identify, to pick the first record of this stream. Okay, I probably should show a stream a little bit so you know what's in there. So it's ADT, firm measure, to measure. This is router ID, the router ID, and this is route name and router ID. Essentially, we use router ID as the unique ID, and to measure, yeah. Start queue and end of queue, ADT value. So this is the test data stream coming in. I picked the first one just to set the measure equals null. So if you can, I'm hovering over here, you will see the start queue is set to null value. And the way to set to null value, by the way, is you can actually pick here to set null, because there's no other way to do it, only doing this thing. And then I further make another one to make the end measure being ABC. So think about your stream can be dirty, right? Which things happen like that. And so when we build this straight line, those two will be rejected. So I'm running through this, and so we have two being rejected. And this rejected, if you look at the reason code, was interesting. They all complain being failed check of number, rather than failed to complain, say one is null. This is actually, to me, this violates the relational database norm, typical definition of what is null. null is not a value. Null can be associated with any data type. So what it should have done is the end measure should be, say, valid null rather than, no, the full measure. Full measure is, but anyhow, it catches these two situations, fail to draw it. Rest of those become straight line. You see, hey, how come there's only one straight line? Again, this is abstraction. We do not really care about where they are. But if I highlight them, so you can possibly see they are each and every things all along this particular line. Yeah. So all individual lines over here. Yeah. I guess you couldn't really see very well, but if I zoom further in, yeah, like this. So now we successfully build converting a descriptive location into an abstract location using Streamline diagram in Streamline format. And you'll see how we did this. And by embedding this here, this allows us to look at its logic. So any of the LRS transform we publish over there, these are all open, so you can embed and then you can explore what's going on. In fact, here, essentially, coming over here, we first remove the original geometry, if it has. In this case, I guess we don't even have that. So we first remove that. Then this is the validation. So this is where the validation is done. Say type equals number or should not be null. If they are null, or if they are other things, then we just pipe this over and make a definition of it. So this is define the reason of what that is. Yeah, and define the reason code of that is, for example, we specify this, so give it more descriptive reason for that. But for the rest of those, as long as we identify them being full measure is less than 2 measure, or less or equal to measure, we are going to go ahead to compute to create this geometry. The vertex creator does the magic. Essentially, it creates vertex by specifying the XY, make a point, specifying the XY values over here. So I just create 2, it becomes a line. If you create 3, becomes, yeah, if you create a closed loop, it becomes a polygon. It's pretty, yeah, it's pretty flexible. So it's really simple, but it's remarkably important in this line of LRS transformer computation. Is a foundational thing. Okay, now let's move on to looking at the temporal aspects of that. So I have another stream. This is ADA sample. We pick a bunch of, in fact, if we look at its value, we don't have, the reason we don't have full measure, 2 measure, because this is LRSN, this age is valid. And if you go down over there, you have ADT, then you have through lane, you have urban code, and you have essentially a similar single string combining route with other things, combining abstract them into single string, using additional attribute as another dimension to separate them, is give us more flexibility, and our pattern will be easier. Later, when we talk about pattern, I will have further comment on that. Then this test is basically saying, okay, we're only looking at ADT. So I just say, hey, the feature, we're only interested in feature name equals ADT. That's it. Then we feed into here, and we're going to run this. It's actually, I ran it already. Zoom out, zoom to extend. Yeah. So now we're looking at the square. Bunch of squares. So if we come over here, you'll see all those squares. And the Y dimension represents time, of course. Yeah, so we could also zoom in to the individual ones. And if you do further analysis here, you can see there are overlaps over here. For AEDT, should not have, in a time-space diagram, we should not have overlap. So it illustrates that this data, some places actually, you see some places actually worth saying. Most likely, this is another error, most likely. It's almost a point of that. Yeah. So this indicates, allows us to see quite a bit of errors. We might be able to, I don't know if we can select that. But anyhow, so this is how we've seen the result of the ADT value being overlapped in time space, which shouldn't happen. And by left click, by embedding it, by edit it, we're able to dive into it a little bit deeper to see what's going on. Essentially, I'm getting the same thing by first, let me zoom this up a little bit, by first removing its intrinsic geometry so that we can create the abstract geometry, like say validate, this is actually not validate, I don't know why. This is just build, yeah. Vertex, yeah, Vertex build, I need validation is over here. So here's the validation, the same thing as we do. And finally here, we're just creating at a point. So it's magically, if the 5 points form a closed loop, it becomes a polygon. In this case, it's square. Yeah. So it's pretty, I thought it was pretty simple, but yet elegant. Most importantly, it's pretty powerful. So this is behind the scene of the two fundamental building block, if you will. Okay, I need to switch to single stream here. So let me, the stream, come on. Okay, have it. Present. Engine. Yeah. Okay, stream patterns. So we have the dual stream pattern, and which is very typical. I think Esri and maybe other LRS tools when it comes to overlaying things like this. Okay, so you have ADT and function classification. You use the LRS line on line and create A and F combined. Then you do another one to use urban code to have the A and F in urban code. Then you do another one, then another one. Finally, you get to the tops, because tops is a combination of 5 key attributes, key events, if you will. But imagine you want to have 20, 30, it's really not very manageable. This is where the single stream really shines. All of them come to a single stream, then output as tops. And it's such a great saver, because we've been toiling through this for years. I've been doing this. And later said, there got to be a better way. And we successfully implemented the single stream only recently. Now I need to switch again. So, okay, I am going to, I'm not saving this, going to have we have a single stream demo. Yeah, you see how simple it is. This is all it takes. And this is the very same sample data I showed you. And that's actually one going through here. Yeah. The same thing, we start with LSN, and then we have ADT and a few other things. That's why we start. And here test, this test is to separate the route from events, so that route goes into the route port. Remember here I say the route feature, specific saying we need geometry of it. Okay, and because we're doing event QC, we don't really need geometry. I need to take it back here. We also abstract route as measure. So I will make a note. Let me make a note so I remember to update this in the final version of it. Remove a feature in the route port. Okay, and then all the other vectors come as the events. We assign unique value, because why we need unique value? So that we can tie back to it easily, yeah. And then we just run this QC here. Okay, we have 3 rejected. Let's look at what's wrong with them, okay? Yeah, we didn't fake anything. This is actually coming through I8 data we recently get. Essentially saying full measure larger than 2 measure. Yeah, this is showing the issue over here. And it is on this particular through lane with particular count number, so that if you can tie back here, getting access to the original full record set. Yeah. Then look at the output of others. Yeah, I think we have some issues why we have all these things over here. I don't quite understand. We still we have something need to fix. Yeah, my intention not to have that. Oh, I don't understand why we have that. Maybe some other things in a way. But anyhow, it shows out of bounds extent. So for this particular record, with the event, the first event ID by itself, essentially by this event alone, we're having the extent outside the extent of the route, okay, on I8, I guess, yeah, in this case. So, so this is it, and let's look at some other type of errors. Yeah, it looks like we only have this error. Yeah, that's quite interesting. I thought there was more errors like like some overlap. I wouldn't be surprised to have overlap. But anyhow, and again, we can embed. Then we can edit, and this slightly a little more convoluted, but nevertheless, we can take a look at it. And here's preparing it and making sure only the events that having corresponding route bring over. So if some of the events or some of the routes, I think this is more to reduce the pipeline for route, because you might have entire auto routes, but event is only on 1 or 2 event on 1 or 2 route of interest. We like to use this to reduce pipeline. Then here is the converting that into streamline diagramming, and here we get a measure of the route, because this is the route portion of it. Then we remove geometry, then do a few acrobatics, and do one of things. And here is the non-line overlay for all the events over here to generate Then going through this pipeline, have a few other things, line-on-line overlay. This is line-on-line overlay for the intrinsic line-on-line overlay. This is line-on-line overlay directly using the event line-on-line overlay. Then here's redirecting the traffic for the output, so that output to be consistent. It is convoluted here, but certainly is, I would say, below average in terms of complexity. It can be, but the good news, it's all visual. And the even better news, if we run it again, you have the chance to examine where things stand and where things might break. And the cache option that is only available in less than 2 years is such a godsend for developers for us. Everyone using FME, you need to consider yourself being a coder, a developer, so we can troubleshoot and give you great visibility into the logic and to adjust what you need to do to get things going. So apparently here I know why, because I forgot. John, you should have tell me to do this, because I forgot to turn this on. Because only the extend being the default. Yeah. Apologize. So let's run it through again. This time we'll have more errors. When you have the cache turned on, the performance is slower. So in production environment, as one of the typical best practice, one of the common best practice is just to avoid having that, yeah. Okay, we have short segments under less than 10 feet long. Because if we have the short segment specified here, this minimum allowable, this is maximum? Yeah, maximum allowable. Okay, another Chinglish sneak into my program here, because I'm constantly battling my language. Minimum, change to maximum. Because you know what? Everything in Chinese is just opposite. Like last thing, first thing, like time, we're upside down. I somehow still cannot overcome this, let's say, after 30 years to be in this country. So this is a short segment. In the case of short segment, we identify, I guess, location. I don't know if it's actually location here. Yeah. So it shows the streamline of the short segment where they are. Of course, only in the abstract form. Then we have overlap. When it comes to overlap, we identify which events are overlapping by how much. By looking at this, you see, is there a minimum? Okay, and that's overlap. We should have other forms. Overlap. Extend, yeah, extend by default. Gap. Partial coverage. So here, what's interesting, you see, this is again the recent addition as of this weekend. Now we not only identify gap from here to here of this length. In this case, it's just over 1/10 of a mile, but we'll also specify the gap is in between this event and this event. So by linking this event unique ID, you can get right to the two events. Maybe they should be connected. You shouldn't snap them. So this is really a latest, more powerful addition to that. And that's, yeah, if we come back here, you will see all these ports coming through, being populated. Yeah. And that, I think, is my, let me switch back to, perhaps I have one last slide. I don't quite, yeah. And Yeah, speaking of feature development, I think we're going to expand the single stream pattern. We really reap the benefit of it, making it much cleaner, easier to maintain. And one other thing is adding more LRS custom transformers to support the spatial temporal nature of our events that exist in real life. And with that, yeah, I'm open to questions. Yeah.
Do we have, this is Eric, do we have any questions? Feel free to unmute and ask, or drop them in the chat too.
So Bo, I've developed some transformers in the past, custom ones.
Mm-hmm.
So do you have like best practices, tips for working with attributes, and then also for dealing with scenarios where like errors and that kind of stuff?
Yeah, I think many people, they all have their favorite list of best practices. Faith, they also published quite a few things. We can certainly share some of our lists. In fact, just internally at ADA, our ADA team started a FM workspace review process because we firmly believe developing FME is akin to software development. There needs to be peer review. There needs to be a more rigid maintenance process to go with it. So much so, we even believe that FME is even more, I think FME even more so compared with other languages because they keep pushing new products or new versions. Each time if you need to leverage something, we have to have things updated. But update can always oftentimes cause, I always say always, sometimes cause some issues. So one of the things, keep things updated. But that's kind of one thing. And I'm mentioning about the review process. The first thing we do is internally we sit down, sift through our internal dozen rules. We always keep a dozen rules. And if some rules that we tend to be mastered, we kind of engrave into our ethos when it comes to FM development, we drop it. But we keep finding new ones, adding to our internal dozen rules. And so usually this will accumulate. And we will be more than happy to share with our rules and our best practices. And generally speaking, right off the hat, I do not know your thing. I think we need to limit the pipeline as much as possible. Just throw away, remove the events you don't need or the geometry you don't need because you don't see it, or even if you see it, a geometry sometimes you don't even see it. If you don't need it, drop them because it eats up your memory space, eats up your performance. And so the attribute remover or attribute keeper oftentimes is one of the things I do. One other recent thing I can think of, especially as you are dealing with data coming different consultants, or there's a lack of the naming convention, and just standardize, maybe use a renamer to uppercase or lowercase all events, so you don't run into issues of a snake case of route ID versus route with uppercase I and uppercase D being different, right? So these are some things I can say, and there's so many aspects of that. So it's yeah.
You mind if I jump in real quick?
Sure.
So David, that was you who asked that question, right?
Yeah.
So in terms of that, typically, I think the most prominent thing we do in custom transformers, and what I noticed that Bo was a little confused about in his process there, is we don't carry through, we typically don't carry through attributes. So in that screenshot where we had all those null values there, typically what we would do is, as we pipe data into a custom transformer, we remove all attributes except for what we want to go into that custom transformer. And then immediately inside that custom transformer, we would then add a creator to create the attributes in a standardized attribute value. So we know inside of the custom workspace what the attribute values are. So for instance, we might map, route ID to P_route ID, indicating it came from a parameter there. And then at the end of that workspace, again, we would use a keeper to only pass the relevant attributes back out of that custom transformer, and then use that counter Bo showed or the object ID to join the relevant attributes back to the output of that custom transformer. So that's kind of our typical workflow we would do for a custom transformer. But then additionally, kind of what Bo was just touching on, our workspace reviewer that we've been implementing, we often find it really, really difficult to maintain the workspaces and keep everything up to date. So Bo, can I share my screen really quick?
Absolutely, yeah, let me stop mine.
Okay, so one of the most recent things we've implemented that I think might be of interest to the community here is FME has the ability to read workspaces and gather attributes of that. And so in light of that, I have kind of created a process here that queries every workspace we have recursively through subdirectories and groups them by directory, and then lists the number of upgradable transformers within that workspace, and then emails Carol, myself, and Bo and I. And again, we literally just created this process a couple days ago, and so we haven't gone back to begin upgrading these workspaces. And a lot of these workspaces are legacy ones that haven't been used in a year or two because they were for a process or a product that's no longer being implemented. But these are kind of our general rules whenever we talk about custom transformers is, only carry attributes that we care about into it and join attributes at the end with the output. And then really trying to keep things up to date and documenting what that process truly is. So I'm not sure if that is kind of what you were asking, or if you were asking a sort of different question, but that's kind of what we've been doing here.
Yeah, I think that's definitely good to see that. And I'll throw this out there for everyone else too, is that there is a project or a thread on the community that has, it's from several years ago, but it's really good with the workspace that you can run that basically gathers up all your statistics and about your workspace and lets you know like things that you can improve upon.
Interesting.
Best practices. I have to post that on
our
group.
That maybe to the group chat and
yeah.
group, that'd be great. Because currently we've just been using the workspace reader itself. So I use a file directory path name reader to gather all FMX, FMW files and then pass those in a single stream over to an FMW reader. And then from the output ports of the statistics, the transformers, the reader writer stuff, we can begin to query this stuff ourselves. So it would be interesting to see how SAFE's approach to that has been done.
Thank you, John. That was a really good comment. And David, I would also think doing FME, looking for patterns, doing more consistent patterns, more efficient patterns, and abstract your old patterns to make it more repeatable. That's always fun and important and efficient. Yeah. And abstract, making sure more reusable, just like in program, in traditional programming, we'll say don't repeat yourself, right? And the same thing, just don't repeat yourself, and using custom transformers, either embedded or linked, oftentimes, and if you have a sizable implementation, that way you can genericize it so you can be fully reusable by passing parameters. And I know for many people only just started using FME, it's a matter of actually keep using it and, attending like FME in transportation and other platforms and just seeing how other people do it. It's actually fun. I really enjoy my FME journey. It's starting actually 10 years. It's to me, it's my geeky side of myself really having a chance to be indulged in playing with it. I'm done. Thank you, everyone. Appreciate it. Yeah. John and Eric.
Thank you so much, Bo, for that awesome presentation. I hope the community found that helpful. I know we only showed a couple of the different LRS transformers in use that we have up on the hub, but if anyone has questions, obviously feel free to reach out. And again, they're all freely available. You can go up there and download them and play with them yourself. Certainly test them out. They're really cool and they're really effective. So again, yeah, thank you to Bo.
Oh, yeah, I'd like to add one more thing. Not all of them I touched upon being available on the hub, but reach out to us. The reason being some of which is not kind of more specialized, the other they are not vetted to be qualified to be on hub. Because if we expose to the whole world, we make sure it's actually being robust. And of course, we cannot say even the ones we up there is good enough, but mostly because we are using it in our practice and internal, so they should be good enough. Yeah, the others, if you are interested, they are not over there, reach out to us. We're more than happy to share.
Awesome. Thanks again, Bo. And then, just to kind of wrap this up, our next presentation is going to be January 19th. We're going to skip December in light of it being the holiday season. I'm sure everyone will be busy and traveling. So again, it'll be January 19th. And my coworker, Carol Francis, who I believe is on the call, will be showing us her process of how she took every roads and highway event layer in the ArcSD database and converted that to the state highway system detail log that's so coveted in the GIST industry. And I believe that she will be showing as well the ArcGIS Online dashboard that is populated from that. And then I will also give her the PDF report I generated from SQL Server reporting services, and she can show off what the final output of the PDF looks like as well. So it should be a really fun presentation, especially if any of you are struggling to generate this the highway system detail log with solely Esri products. You'll find this incredibly valuable. So again, thank you guys for coming. If anyone has any questions or comments or feedbacks in relation to this special interest group, go ahead and shoot me an email. And especially if you're looking to present or you have anything you want to present, reach out to me. We're always looking for people to present, no matter kind of what the level is. If you're doing something in the GIST industry that's going to benefit other people across the country, no matter what organization you're working for, certainly reach out and we'll get you scheduled to present. And with that, thank everyone. Thank you guys for attending and hope you guys enjoy your lunch break and the rest of your day.
All right. Thanks, everybody. We'll catch you all next month, if not, or January, if not sooner. Thanks.
Thank you.